In Lesson 8.5, Part B, we are going to be talking about the law of cosines. Now, in Part A, we talked about the law of sines, and using that, we could set up proportions to solve. We also talked about the fact that the law of sines means we don't have to have a right triangle. Well, the law of cosines is the same. The law of cosines can be used with any type of triangle, acute, obtuse, or right. It just depends on the given information that you have. Now, basically, the law of cosines is going to kind of look like a big formula. And in my triangle here, I still have angle A and side A opposite from each other, angle B and side B, angle C and side C, again, opposite from each other. It doesn't matter which sides you label as A, B, and C. So side C does not necessarily have to be the longest side. Taking a look at my formula here, it looks a little bit big and scary, but it's really not too bad. It says that C squared is equal to A squared plus B squared minus 2AB cosine of C. So I just want to kind of dissect that a little bit. First of all, you'll notice if we kind of covered this part up, what does that formula look like? Yeah, the Pythagorean theorem. But because we don't necessarily have a right triangle, it can't just be A squared plus B squared equal to C squared. We kind of have to adjust it a little bit. And by adjusting it, we are saying that we are subtracting the product of 2AB cosine C. This is 2 times side A times side B times the cosine of angle C. Now, it can also be written down below when I may be taking A squared and putting out front or B squared and putting out front. But notice what changes. Whichever side is out front, or what we're equaling it to, that is the angle that we're using in the problem, or in the formula, I should say. Now, I typically just tend to refer to the law of cosines as this equation. So as we work through, that's what I'm going to refer to. Now, the law of cosines, again, it kind of depends on which information you're given. Let's take a look at how we would set up and solve. Now, I am going to expect you to show me some work when you set up to solve your law of cosines. In question number 1, they're asking me to find side xz. Now, really, I could label side xz as A, B, C, or even x. But typically, if I'm finding a missing side, and I'm going to use the law of cosines, that becomes my side C, which means across from it, this would be my angle C. Now, as far as A and B goes, it doesn't matter which one is A or which one is B. I can label either. I'm going to go ahead and fill in or make those substitutions into my formula. I'm going to use this one up here. And so we don't know C. A squared plus B squared minus 2 times A times B times the cosine of C. Now, when I get to this point here, I really just have to simplify on this right-hand side and go ahead and solve for C. We are going to want to follow the order of operations. And so order of operations would tell me to do my exponents first. This is typically how I tell my kids, if you don't want to write every single thing down, what I'd like you to do is to break it down and take 35 squared plus 30 squared. Okay, so I know this would actually be 1225 plus 900. We're squaring them, we're adding them together. So this is going to give me 2125. I am subtracting, but if I were following an order of operations, we would be multiplying first. And so I tell kids to go ahead and multiply that product right there. 2 times 35 times 30 times the cosine of 110. Actually, we're going to take 2 times 35 times 30. And I'm going to write that down as 2,100 times the cosine of 110. And the reason I'm doing that is because I don't want to have to give a rounded answer. Now, would you agree that in order to solve for C, in the end, I'm going to be having to take the square root? Okay. Now, a common mistake is that kids want to go ahead and subtract this. But I cannot subtract 2125 minus 2100 because this is being multiplied by the cosine of 110. So C, in the end, is actually the square root and because I don't want to give a rounded answer, I'm going to punch that into my calculator all in one. So I'm going to say we need the square root, 2125 minus 2100 times the cosine of 110. And our calculator knows to follow the order of operations. And as I calculate that, I can see that C is going to be about 53.32 to the nearest hundredth. Okay, let's take a look at number 2. I take a look at number 2, we're looking to find side DE. So again, when I'm looking to find this side length, even though it's the shortest side, I'm going to call it side C. Because in my law of cosines, that's when I'm looking for a side length, that's what I label it, which means that this angle here is going to be my angle C. Again, side A and B, it doesn't matter which one you have, A and B. We're going to set up and solve. C squared equals A squared plus B squared minus 2 times A, B, cosine of C. And we're going to go ahead and just break it down a little bit. We're going to find this product here. Following order of operations, 16 squared plus 18 squared. Well, I know that's 256 plus 324, but you may not know that off the top of your head. So if you just calculate your product here, you can see I added those two together. I'm going to get 580. And then I'm going to go ahead and multiply 2 times 16 times 18. And we find out that we get 576. Now again, this 576 is being multiplied by the cosine of 21. Okay, so I can't subtract. But when I look to find C, I know I need the square root. So I'm going to go ahead and calculate. The square root, 580 minus 576 times the cosine of 21. And we should always just kind of ask ourselves if our answer makes sense. Does it make sense that my answer could be 6.50? Well, when I look at my triangle up here, and I have legs of 16 and 18, but this third leg we're finding would be significantly smaller, yeah, I would say that it would make sense that that side is 6.50 units. Okay, so that's what we are going to do for calculating to find our side length. We can also use the law of cosines to calculate and find the angle measure. We're going to kind of approach it in the same way. You'll notice here, though, that I have all three sides of my triangle. I know the three sides side lengths, but I'm looking for the measure of angle T. Okay, measure of angle T is what we're looking for. So if I'm looking for the measure of angle T, this is actually the angle then that I'm going to call angle C. And if I'm looking for that, then this is going to become my side C. A and B, again, doesn't matter which one you have as A or B. We're simply going to plug in our information here. I know what C squared is. Okay, I'm going to plug in 7 squared, A squared plus B squared minus 2 times A times B times the cosine of C. And this time I don't know what that angle is. And so here we're really looking to solve for that variable. I'm going to do a little bit of simplifying, okay? I know that I need to do my exponents first, 49. I can again kind of approach it the same. I know this is 121 and 169. I can add those two together, okay? 121 plus 169 would give me 290. I'm going to go ahead and multiply 2 times 11 times 13. Well, 2 times 11 times 13 is 286. But this is times the cosine of C. So I have to remember that that's treated kind of as one chunk there. I cannot subtract. The question is, where do we go from here if I'm solving for C? What do I do? Well, really, we would need to start by getting rid of my 290. This is a positive 290 degree, positive 290, and we're solving for C. We're actually going to take and subtract 290 from both sides. 49 minus 290, we're going to get negative 241. On my right-hand side of my equation, the kind of trick here is this negative sign is still here. This is negative times 286 times cosine of C. And so I can't forget that. I can really kind of treat it like this. What do you think I'm going to do? If this negative 286 is times by the cosine of C, and we're solving for C, we're actually going to divide by negative 286. Now, if I take in my calculator and I take negative 241 divided by negative 286, I'm going to get 0.84. Does it make sense that 0.84 is what my angle C is? No. 0.84 is what the cosine of C is. So how would I find the angle measure? Yes, to find the angle measure, I need to use the inverse function. So I actually need the inverse of that answer. Now again, I don't really want to round that to 0.84. I'd like to keep all of the digits. So I'm just going to hit second cosine, second answer. And I'm going to use that answer button right down here. It will recall that complete decimal, and we will take the inverse of that. Now, it tells me that angle C is about 32.6 degrees. That makes more sense, seems more reasonable, right? About 32.6. Now, on my paper here, what I'm going to write is that the negative 241 divided by negative 286 is the cosine of C. And so in order to find that angle measure, what we did was we took the inverse cosine. Of course, we kept that decimal on our calculator. And we found out that C was about 32.6 degrees. And sometimes they ask us to round to the nearest degree, so it would be about 33 degrees. This as the decimal was about 0.8427 and so on. So we just have to remember, if you're finding the angle, the final step, we need to use the inverse function. Now, how do we know if we should use the law of sines or the law of cosines? Well, as I said in the beginning, it's actually dependent upon what kind of information you're given and how your triangle is set up. If I take a look down below, using the law of sines or law of cosines, I kind of have it summarized here. If I were given an angle-angle side, or a side-side angle, or angle-side angle, this would allow me to set up with the law of sines. If, however, I had a side angle side or a side-side side, I would need to use the law of cosines. So I'm going to expect that you are able to tell which one you would use to solve for your missing information. For example, if you look down below at the first triangle and I was solving for x, and let's say, typically people like to use the law of sines because it's pretty short and sweet. But if I try to use the law of sines and pair them up with opposites, because I don't have any angle measures, I can't use the law of sines to find my value for x. This given information I have is side, side, side. So up here, side, side, side tells me I would have to set up with the law of cosines. So I'm just going to make a note here. I would use the law of cosines because I have side, side, side. Now, I decided I'm not going to go through and set up and solve. This would be just like the example from above that we did. If you wanted to try that out, I believe that in the end, your angle measure should come out to about 48 degrees. Now, you remember if I were setting up to solve this, this would be my angle C, and so this would be my side C. Let's just take a look at the other triangles and see what we think we would set up, law of sines or law of cosines. Sometimes I just try the law of sines, and I know if that doesn't work, then I can go to the law of cosines. I try to match them up, opposites. Well, this I can see that would work. When I can do that, I can use the law of sines. But also looking at my given information here, I have angle, angle, side, or side, angle, angle. So that would meet this requirement right here. Triangle 3. Well, I could pair these guys up. That's about it. When I look at my given information, I have side, angle, side. Well, side, angle, side, looking up here, would actually tell me that I need to use the law of cosines. If I were setting this up with my law of cosines, then this would become angle C and side C, and I would have my A and B or B and A. Given information. Sometimes this last one can throw people for a little bit of a loop. Oh, actually, not too bad. These would match up. And these would match up. What do I have here? Well, I have side, side, angle, or angle, side, side. And so that tells me the law of sines. Okay, if you have further questions on this, please stop in and see me. I will also post a couple more additional example videos on the website.